Okay, we actually have 7 laws of indices, and this is the seventh law of indices. It is called fraction index. When we said here that we have a zero index, okay, when the power is zero. When we say negative index, when the power is negative. Now we are talking about when the power is a fraction. And what is a fraction? A fraction is something like this that has a numerator and denominator, right? To do that, we are going to involve what is called roots. I think from our primary school, we were taught square root of number. The word square means 2. All right. When I say square, square means 2. Then if I say square root, for example, if I say 5 square now, you say 5 raised to power 2, right? That is 25. You know that. N square is always like this. Then if I now say that same word, square root, it talks about, or you're thinking of a number that you multiply twice. But mathematically, it's not ideal that we write the 2 here. It's invincible. Just like in mathematics, we don't write 1x. You know it's invincible. Starting from 2x, this value can show. But here, no. The same thing is applicable to square root. Square root, the 2 will not show here. That means that we have other roots aside square root. So after the square root, if I talk about other roots like cube roots, I can have cube roots of a number of 8. I almost put 3 here to tell you that this thing is not a square root. I have cube root, I can have 4th root, I can have 5th root, I can have 6th root, 7th root, 10th root, and so on. All right. So now we are dealing with roots. So if I write something like this, it means square root of 8. It means square root of 81. It means a number that you multiply twice that gives you the number in the square root symbol. So that is 9. I can have the square root of 16 as 4. 4 times 4. Twice. But I can also have cube roots. That is a number multiplied 3 times that gives me this number. That is 2. 2 times 2 times 2 is 8. So the cube root of this is that. I can also have the cube root of 27. That is 3. 3 times 3 times 3. I can have the 4th root of 16 as 2. I'm trying to remind us about roots. Okay? That it is not only the square root that we have other roots. Now, when we are dealing, let's come back to fraction index. Okay? Now, to know this, that's why you must know all these roots. What do you now do? You are going to apply this. Don't forget that this is the base. The A is the base. This is the fraction. And in the fraction, we have the up to be numerator, the down to be denominator. So whatever the value of the denominator is going to be the root. If the denominator is 2, that will be square root or something. If the denominator is 3, that will be cube root. If it is 4, 4th root. If it is 10, 10th root. It now depends on the value of the denominator, because the denominator is going to carry or serve as the root. Now, to solve that, I'll just say the nth root, this root will now carry the base. Then everything raised to the numerator, that is m. Let's look at an example. What do we observe here? The decider here is our denominator of the fraction of the power. And the denominator here is 2. Then I'll put it in root form. 2 in root form is square root. Because of this 2, that will be square. So I'll say square root of the base. Everything raised to power 3. Then I proceed by saying, what is the square root of this 4? Is 2. Then 2 raised to power, you continue. 2 raised to power 3. That is what? 2 times, that is 8. 2 times 2 times 2. I can also have 8 raised to power 2 over 3. Now, in this case, our denominator is the decider again, like I always said. The decider is 3. And I will now put 3 in root form. That will be cube root of the base. Then I will now say cube root of 8 raised to power 2. Then I now find the cube root of it. That is the number I multiply. No more twice now. This one is the number you multiply 2 times because it's square. Square means 2. Cube is 3. So the number you multiply 2 times that gives you 4 is 2. This one now, the number I multiply 3 times. For cube root, 3 with anything that is more than square root will show here, because we must know the number of root it is. If there is nothing here, that means it's in square root. But because this is 3, it's not more square root, it is now cube root. If it is 4, fourth root. Alright? So this is the cube root of the base, that is 8. So what is the cube root of 8? What is the number I multiply 3 times that gives me 8? That number is 2. Then 2 is power 2, that gives me 4. We have other examples. Let me just add one more. Also do this. 81. How do I solve this? Our denominator is in root 4. That will be the 4th root. Very good. 1. Denominator is 3. And that you multiply 4 times at the same number. That is 3. 3. So that a lot of people will not think that it's because of this 3 that I'm putting here. So 1, 1. So 3 raised to the power 1 is 3. If it is 3 raised to the power 3, of course, that is 27. This thing can also be in form of a fraction. I can have 16 over 81 all raised to the power 3 over 4. What do we do? Very easy. The denominator, this whole thing is the base. So the denominator here is 4. That I'll take the 4th root of the two of them, 16 over 81, all raised to the power what? 3. Then I will now apply, because of the law of sort, that that root covers the two of them. So what you do here, you do it to this place. So I will take the 4th root of 16 and also the 4th root of 81. So the 4th root of 16 is 2. 2 times 2 times 2 is 16. Then the 4th root of 81 we have done here to be 3. That is 3. Then everything is to power what? 3. With this idea, look at it. 2 raised to power 3. This power is for the two of them. So 2 raised to power 3 is 8. Then 3 raised to power 3 is 27. So the answer is 8 over 27. Then we can also have when the power here is negative. Don't forget that we have treated negative power. So if you don't want to apply that 1 over yet, of course you can start using the law here. That's the denominator here is that means I'll take the cube root of 27. Everything raised to power minus 1, not 1. Don't throw the minus away. Then what is the cube root of 27? That is 3. 3 raised to power minus 1. Then you know what this one will give you. You take negative index. You know that it's not allowed. You see 1 over the same positive value. So 3 raised to power 1 is 3. So I'll give you this as an assignment. You can just try this. 16 over 81 raised to power minus 3 over 4. Okay. You can try this. All right.